everyone, we're on day 7 of our notes. Let's get to it. So what have we learned so far? We've learned SSS, which just means that if two triangles, well, those aren't the same size, Robinson. If two triangles have all three sides corresponding, so I have this side is congruent to this side congruent to this side, and this one congruent to this side, therefore we can prove SSS. We've also done some SAS. Well, what on earth does SAS mean, Miss Robinson? Well, let me tell you. SAS means that the angle that is sharing the sides is congruent. And then there we go, the corresponding angle on each one. And this side congruent to this one, and then the one on the other side of the angle. So SAS, that's what it's spelled, S-A-S, and I write it down. And then the last one, things to keep in mind. So you can prove that these two angles are congruent based on vertical. They are vertical angles. You can also prove reflexive, meaning if triangles are touching, oh la la, then you can say, oh, well, this side is the same as this side because it's the exact same thing. Okay, so you can also prove reflexive. So if it doesn't have these dashes, okay, or these curves, just know that you can look at the angle, look at these two angles and prove that they're congruent based on vertical angles. Again, and then if these two triangles are sharing a side, you can prove, well, this side is the same. Now we're going to focus on angle, angle, side, and angle, side, angle. So today is angle day. Whoop, whoop. So if you notice, angle, angle, side is AAS. So that means that this angle is congruent to this one, and this angle is congruent to this one. But let's look at the order. Angle, angle, side means that the side is not in between them. It's actually over her. Okay? You could also have the scenario where you have angle, angle, side. Okay, let me add my colors because you know I love a color. You could also say it's this one. Angle, angle, side. So as long as the side is not in between the two angles, you can prove AAS. Now, I didn't say that bad word. I said AAS. All right, now let's do angle, side, angle. Okay, side is now in between. It's sandwiched in between the side. Okay, so I've got angle, which corresponds to this angle. I've got this angle, which corresponds to this one. And what is the side that they are sharing? It's the one in between. So read it out loud. Angle, side, angle. Okay, so remember what the bad word was? Oh my gosh. So there's no ass, oh my gosh, in geometry. Right? So I can't have two that have two sides at an angle. Oops, I won't do that one. Let me draw different ones, y'all, because I don't want you to get confused. So you can't prove these with ASS. No way, Jose. All right, so that means that there's an angle and a side. But you can prove with AAS. Okay. So it's a little bit trickier. So ASS, no bueno. AAS, muy bueno. All right, so let's draw some pictures, y'all, and let's get to it. So A, B, C. So I've got A, B, C. And look at the order of how I write it. So A was first, so Z is first. B corresponds to X. C corresponds to R. Okay, so angle C is congruent to angle. All right, make little adjustments. So C goes with R. Okay, so cross that out and put an R. A goes with Z. And AB goes with ZX. Okay, so again, this order really matters. That's why I had to fix number 1. So A, B, C, and Z, A, B, C, and Z, X, R. Okay, so if I look at it, I have angle, angle, side. The side is not sharing the angles, so I'm just going to write AAS. Okay, based on I have 2 angles that are congruent to each other and then a side. Okay, now let's try this next one. Again, I have to fix it. I apologize. So I'm going to have DEF and BOG. So DEF goes with BOG. So angle D goes with angle B. E goes with angle O. And DE goes with BO. So let's look at this. We have an angle and we have an angle, but where is that side? Okay, well, it's sandwiched in between the 2 angles, so I'm going to write angle, side, angle. Okay, so remember, so number 1, I had to change the X's to R's, and then number 2, I had to change it to BOG. All right, determine if the following triangles are congruent, and if so, why? Why not? If yes, write the triangle congruent statement. Okay, so I have these 2 angles that are congruent, and I have these 2 sides, and then I have this one that's also congruent. So let's look at those dashes, y'all. The dashes matter. Okay, so if you see 1 curve, those go together. If you see 2 curves, G and K go together. And then if you see dashes, that means those sides go together. So it's ASA, and what is the triangle congruent statement? So FEG, so triangle FEG is congruent to, so look at the F, what else has 1 curve? J does. And then look at E, what corresponds to E? H. And then what corresponds to G? K. So FEG, and I forgot my little triangle, is congruent to triangle JHK. All right, now let's try this next one. So I have 69 degrees, so those are congruent. I have these 3 dashes, so that means that's congruent. So I have a side, and I have angles. And now I also have 1 more angle, which is 53 degrees. Okay, so let's look at the order. Is the side sharing the angles? Okay, is it connected to the angles, both of them? No, it's not sandwiched in between. So I would write AAS, and now I'm going to write my congruent statement. So I have NML. Again, it doesn't matter what I start with, but as long as it corresponds to the other one. Okay, so NML is congruent to triangle CBA. So NML CBA. Okay, so that's my triangle congruent statement. So I write down which one is it, ASA or AAS, and then I write down my triangle congruent statement. So I want you guys to try this one. So what do we have? So I have 2 angles, and I have this angle. So right now I only have angle. But what did we learn about when they share a side? They share a side, I can say that it's reflexive. What does that mean? That they're the same. So I have angle, side. Now write down that triangle congruent statement. So XYW goes with what? So triangle XYW is congruent to ZYW. Triangle ZYW. Okay, if you notice, YW is in the same spot because they're the same line. Okay, So this is remembering sharing the side. Now let's look at this one. What do you notice? I notice that this angle is congruent to this angle. Okay? Because I'm a magician. What? Okay? These are vertical angles. So that's one of the only times I can say for these triangles that these are congruent, because I can prove that they're vertical. All right, I also have two angles that are congruent, and I have a side. Now I just need to see, is it AAS or ASA? Okay, is there something sandwiched between the two angles? No, so therefore it's AAS. Let's write down our triangle congruent statement. So Q, if I start with Q and I go to P, then O. So Q, P, O. Again, it does not matter which one starts it, but you got to figure out what corresponds to Q on this triangle. Well, Q and M would go together. What else has the 90-degree corner? P, so that's N. And then back to O, because O. All right, for this next problem, I need you guys to change it. I want B and E to be congruent, not A and E. So I apologize again. It's really tricky to make these, so thank you for your patience. So F goes with F because they are vertical angles. Okay, so what do I have here? I have B and E go together, and I have A and DF, and then I need angle F. Okay, so I have triangle BFA is congruent to triangle, what goes with B, E, and what goes with F, F, and what goes with A, D. Okay, is there another way to write this? Absolutely. Let's say I wanted to start with A. So what if I wanted A, B, F? As long as your corresponding letters go together, we're in business. So what goes with A? D. What goes with B? E. What goes with F? F. So please don't stress about the order. As long as you know that the B goes with the E, we're in business. Let's write down the theorem. So it's angle, angle, side. The side is not in the middle. So angle, angle, side. Okay? Right there. All right, for this next example, because it's overlapping, it's kind of hard to see unless we redraw it. So please follow along as I do this. Okay, so I have K, G, L. I have H, K, L. I have 90-degree angles, K and L. And I have GK and HL. All right, now, right now I have side angle. Now let's look at this bottom line. If you notice, they are sharing it. This is reflexive. KL and KL and LK mean the same thing. So we're gonna be writing, what type of angle theorem is it? Side angle side. SAS. All right. And how do I prove it? Well, you got to be careful on how we write it. So what does G go with? Well, G goes with H. So that helps us out. So these are the top angles. And then G has to go with K if I'm going straight down. So what would go with H? Well, L would go with H. And then what is the last letter remaining? Well, that is L. And the last letter remaining for this one is K. So if you notice, the KL and LK are swapped. Okay? Because the triangles are overlapping each other. This J kind of just lets us know about these angles, which doesn't really help us in this situation. So if you notice, let me show you. I have GLK and HKL. All right, so those are the two triangles that are overlapping, and then that's why we have SAS when we are solving it. All right, let's see what we have here. We have two angles that are congruent. We have a side that's congruent to a side, and because these are vertical, they are congruent. So I have angle, side, angle. And now I have to prove that the triangles are congruent to each other. So let's figure this out. So L goes with J. It corresponds with each other. G goes with K. And H goes with H. All right, we're almost there. So let's do this one, and I'm going to redraw them so I can see it better. So I have AEB. So I have a side and an angle. So is that a way I can write it? So SAA is the same thing as writing AAS. It's just in a different order. It's all good. Angle, side. Whoop, whoop. Let's write our triangle congruent statement and move on. AEB is congruent to triangle CDB. Whew. So the B's went together. They both were at the 90. The E went with the D, and the A went with the C. It's very helpful if you redraw it when it looks kind of strange or kind of sideways for these. We're almost there, guys. So AB is congruent to DE. AB is congruent to DE, and these are congruent. Oh, mama, and these are parallel. Now, why on earth does that matter, guys? Well, if they say something about being parallel, you need to think about alternate interior angles. That is your money maker, people. What does that mean? B is going to correlate to the one that is opposite of it. So that's going to be with E. Okay? Now, what's going to go with A? D, because those are alternate interior. Bada bing. So we are in business, people. Okay, so what do I have? I have angle, side, angle. So on your paper, if you just circle ASA, that's probably not going to help you because you're going to be like, how on earth, what was I doing that day in class, right? So making sure that you understand where did it come from, reminding yourself about alternate interior angles, showing that these are the same, they're congruent. So if you have triangles that show that these are parallel, knowing that these opposite angles are congruent is game changer, people. Game changer. Okay, now could I prove with AAA? That is not one of the options. AAA is going to help you with your car, not help you with triangles. Not a thing, okay? Because I can have a triangle this big and a triangle this big, and they'll have the same angles, the same congruent angles, but not the same sides. Okay, so AAA will not save you with triangles, just your car. Whew. Last one. Oh, here we go again. We've got parallel lines, y'all. So I've got AB. AB goes with CD. Oh, mama. And then it says B is congruent to D. All right, that helps. Now, what cuts through both of these parallel lines? Well, this one right here cuts through. Okay? So how on earth does that help us? So we got to look at the angles of what we've got. Okay? So we have this option. We have this one and this one. And it cuts through the green line and the parallel lines. So what is that known as? So if I have parallel lines and something cuts through, and it's in the same location. Okay, so that's called corresponding. So if they are corresponding angles, we're in business and they're congruent. So angle A is congruent to angle C because of corresponding angles. I have AB is congruent to CD. How do I know? Because it told me. Hello. And then what did they give me? Angle B is congruent to angle D. Therefore, what do I have? I have angle, side, angle. I'm going to write down the triangles that go together. So triangle ABC is congruent to triangle CDE. And there we go. All right, thanks for joining me on day 7. Hopefully you learned some AAS and ASA, and let us know if you guys have any questions. Have a great day.